Suppose that $15,000 is invested at 3% annual interest, compounded continuously. A. How much will be in the account in 5 years if no money is withdrawn? We'll use the continuous compound interest formula. A is equal to P times e to the RT, where A is the amount in the account after T years, where R is the rate and P is the initial principal invested. In this case, we're told that P is equal to 15,000. R is 3%, and so as a decimal, R is equal to 0.03. And we're asked how much will be in the account after 5 years, so we're going to let T equal 5. Substituting into the formula, we have A is equal to 15,000 times E raised to the 0.03 times 5 power. Evaluating, A is approximately equal to 17,427.51. And thus, if no money is withdrawn, then after 5 years, there will be approximately $17,427.51. B. How long to the nearest tenth of a year will it take for the initial principal to double? Again, we're going to need to use the same formula, A equals P times e to the RT. The principal is still the same. P is equal to 15,000. The rate is still the same. R is equal to 0.03. But this time, we're looking to solve for T when the principal has doubled, or when A is equal to 2 times 15,000, which is 30,000. So we'll substitute into this equation and then solve for T. We have 30,000 is equal to 15,000 times e to the 0.03t. We'll divide both sides of the equation by 15,000, and we get 2 is equal to e to the 0.03t. Since t is in the exponent of our exponential expression, we'll need to use logs to solve. We'll use the property that if x equals y, the log of x equals the log of I. We're going to use natural logs since the base of our exponential expression is e. So on the left side of the equation, we have the natural log of 2, and on the right side, we have the natural log of e to the 0.03t, which is just 0.03t. Now we divide both sides of the equation by the coefficient of t, and we get the natural log of 2 divided by 0.03 is equal to t. Evaluating, we find that t is approximately equal to 23.1. And so it will take approximately 23.1 years for the amount in the account to double.